Betelgeuse, a star known for its prominence in the night sky, has captivated both seasoned astronomers and amateur stargazers for generations. With its notable reddish tint and immense scale, this celestial body stands out in the Orion constellation and is easily visible without the aid of telescopes. Recently, however, Betelgeuse has drawn significant scientific attention for a far more unusual reason: a dramatic and abrupt 150% increase in brightness detected by the James Webb Space Telescope. This unforeseen change has reignited interest within the scientific community, raising fresh questions about the star's current condition and what the future may hold for it. As a red supergiant, Betelgeuse is nearing the final phase of its stellar life. Located about 642 light-years from Earth, it ranks among the largest and most luminous stars in our galaxy. Its size is staggering, roughly 700 times the radius of our Sun, and it radiates with a brightness over 10,000 times greater. Red supergiants are inherently unstable in their final evolutionary stages, often undergoing irregular cycles of fading and intensifying light. Even by these standards, the recent brightening event stands out as a particularly extraordinary occurrence, capturing the attention of astrophysicists worldwide. This major development was observed with the help of the James Webb Space Telescope's advanced infrared imaging capabilities. By looking through thick layers of dust and gas that typically veil Betelgeuse, the telescope provided an exceptionally detailed view of the star's outer structure and environment. What it revealed was a massive increase in luminosity, an unprecedented event that occurred over just a few weeks. The scale and speed of this transformation suggest that an unusual and powerful process is taking place within the star. This observation has added new weight to long-standing theories that Betelgeuse may soon go supernova, a catastrophic explosion, marking the death of a massive star once its nuclear fuel is depleted. While scientists originally believed such an event might occur within the next 100,000 years, this recent activity has fueled speculation that the timeline could be shorter than previously expected. The star's increasingly erratic behavior in recent years, culminating in this dramatic outburst, may signal that it is entering a more unstable phase that often precedes a supernova. Should Betelgeuse explode, the resulting spectacle would be unlike anything previously seen. Its brightness would likely rival or surpass that of the full moon, even during daytime, and persist for weeks. Despite the intensity of such an event, Betelgeuse's distance from Earth ensures that it poses no threat to our planet. Instead, it would provide an unparalleled opportunity for scientists to study a nearby supernova in real time, offering new insight into the mechanics of stellar collapse and death. The recent surge in brightness has also prompted renewed investigation into the inner workings of red supergiants. These massive stars are notoriously difficult to classify due to their vast size and chaotic internal dynamics. Betelgeuse, in particular, has long baffled researchers with its unpredictable light patterns. Understanding what triggered this recent 250% increase in brightness could offer vital clues about the behavior of similar stars and the processes that govern their instability. One possible explanation is that Betelgeuse experienced an enormous convective event, an immense pocket of heated gas rising from the core to the surface. Such convective motion is common in red supergiants and can lead to noticeable changes in brightness, especially if it results in material being expelled from the star surface. This newly revealed hot material have caused the observed brightening by exposing more luminous regions of the star. Another possibility is that the star underwent a significant eruption, shedding mass that formed a surrounding cloud of gas and dust. This material, now illuminated by the star's intense radiation, could also account for the sudden increase in visible light. This theory also aligns with the mysterious dimming event in 2019, which many experts now attribute to a dust cloud, temporarily obscuring the star's light. The current brightening could represent a reversal of that event, with ejected material reflecting and amplifying the star's natural glow. A third hypothesis involves changes in Betelgeuse's magnetic field an aspect of its structure that remains only partially understood. Some research suggests that red supergiants may have intricate magnetic environments that affect how energy moves through their layers. Sudden shifts in this magnetic framework could lead to dramatic changes in luminosity. If this theory proves accurate, the recent brightness spike may be a result of such a magnetic disturbance. This insight could lead to new avenues of research into how magnetism influences the evolution of massive stars, an area that has remained largely unexplored. While scientists continue to closely monitor Betelgeuse, the star's evolving brightness underscores the importance of mass loss in the final life stages of red supergiants. These stars frequently eject enormous amounts of gas and dust, a process that can alter their internal balance and drive further instability. If Betelgeuse is now experiencing an accelerated rate of mass ejection, it may be approaching a critical threshold that could soon result in a supernova. The timing of these developments coincides with a period of remarkable technological capability. The James Webb Space Telescope is uniquely suited to studying stars like Betelgeuse, which are often hidden by surrounding debris. Its ability to analyze the various elements of the star's light spectrum provides detailed information about its temperature, internal structure, and chemical makeup. As Betelgeuse continues its transformation, the telescope offers researchers an invaluable platform to study the final stages of stellar evolution in detail. However, despite the dramatic nature of recent observations, it's essential to remain cautious. The brightness surge, while extraordinary, does not necessarily indicate that a supernova is imminent. Red supergiants are known for their chaotic fluctuations and can undergo extreme changes without reaching the end of their life cycle. Betelgeuse may simply be passing through another phase in its long journey of instability, albeit a particularly intense one. Nonetheless, the magnitude of this recent event is difficult to overlook. A 250% increase in brightness over such a short period is highly unusual and strongly suggests that something significant is taking place within the star. This moment highlights the ever-changing nature of stellar life. Massive stars like Betelgeuse are not static. They are shaped by complex interactions between internal pressures, external forces, and cosmic environments. Studying these interactions is crucial to understanding the life cycle of stars and the broader processes of cosmic evolution. This event also emphasizes that the universe is a dynamic and unpredictable realm. Rather than a quiet or steady place, it is filled with violent changes and energetic transformations. Betelgeuse's current behavior serves as a reminder of the powerful and often mysterious forces that shape the cosmos. What makes this development especially exciting is the opportunity for ongoing discovery. Betelgeuse is now under continuous observation by an array of instruments, both in space and on the ground. These include advanced observatories capable of detecting shifts in various wavelengths, from visible light to radio frequencies. Over the coming months and years, scientists will examine its fluctuating brightness, search for new eruptions, and study the composition of any expelled material. The data gathered from these efforts may reshape our understanding not only of Betelgeuse, but of all red supergiant stars. As the star's activity continues, there's a small but thrilling possibility that we may witness a supernova within our lifetime, an event of immense astronomical importance. Betelgeuse, with its colossal size and unpredictable nature, has long been viewed as a potential candidate for such a cosmic explosion. Whether this recent brightening marks the start of a greater upheaval or simply another chapter in its turbulent life, one thing is certain: the scientific world is watching closely, with global networks of observatories now focused on this ancient, fiery giant, including space-based platforms and ground facilities like the Very Large Telescope in Chile and various radio arrays. Researchers are poised to capture every nuance of its evolution. The James Webb Space Telescope remains a key tool in this effort, offering a level of detail and depth that was previously unattainable. As Betelgeuse continues to evolve, It stands not only as a point of curiosity, but as a beacon of discovery holding clues to the grand, ongoing story of how stars live and die in our universe.